So this is 5.1, and it's about applying the product rule and also the applying the raising a power to a power. So for example, the product rule, the basics for that would be a to the power of m multiplied by a to the power of n will always equal a to the m plus n. And so this only works if all the bases are the same. So for all these rules that I'm talking about, all bases must be the same. Okay, so if we take a look at an example, let's say we have 2 to the third multiplied by 2 to the second. Well, that would be 2 to the third plus second, which gives us a result of 2 to the fifth. And why is that the case? Well, if you expand these, you would get 2 times 2 times 2 times 2 times 2. And how many 2's do you see? I see 1, 2, 3, 4, 5. So that's really 2 to the fifth. And so this is just a shortcut to go, oh, if the bases are the same and I'm multiplying, all I have to do is add the exponents together. Same true for another one. Let's say we have 2 to the x, and the power on the x is a 2. And then we have 5x to the 6. Well, the only ones that have any exponents are the variables here. So that means it's going to be 2 times 5 times, and I've got 2 x's, and then I have 6 here. So 1, 2, 3, 4, 5, 6. Okay? So 1, 2, 3, 4, 5, 6. So if I go ahead and calculate this out, this is 10, and then I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 x's. So these two get added, and that gives me 10x to the 8th. And so that's how this problem works. We can do that also for a more expanded one. Let's say it's got some distributing in it. Let's say it's x to the third, and it's multiplied by 2x plus 3x squared. So I can't add these together because they're not like terms, because this has 2 x's and this only has 1. But I can go ahead and multiply. So that's x to the third multiplied by 2x plus x to the third multiplied by 3x squared. So I have 1 here, so I'm adding, so that gives me 2x to the fourth. And then I add these as well, so that gives me x to the fifth, and that's 3. And this is all I can do because, again, these are not like terms. This one has 4 x's, this one has 5 x's. So that basically explains that. So now if I look at the next rule is called raising a power to a power. So raise a power to a power. Okay? And so that general rule looks like this, where you have a, the base, to the exponent of m, and then we're going to raise it again to the n. And so what that really means is that we would take the base to the m multiplied by n. And this is the general form. So if we take a look at some examples, like 3 squared, and it's going to get raised to the 4th power, then that means what? That means that I'm going to take 3 to the 2 times the 4, which means that's 3 to the 8th, because 2 times 4 is 8. And why is that the case? Well, let's prove it. This 3 to the second has 4 of them, so I would write this 4 times. So that's 3 to the second times 3 to the second times 3 to the second times 3 to the second, because that's what the 4 is saying. So then we would add these up. And 2, 4, 6, 8 is how I get this. And so there's the setup for that. And let's look at a different problem. Let's say it was a variable. Let's say it was a to the third and then to the power second. That just means we're going to take a to the 3 times the 2. And why is that the case? Because I have 2 a to the thirds in the setup. So a to the third multiplied by a to the third. And so I get a to the 6. And 3 times 2 is 6. And so that's basically what's going on in this type of problem, is that type of setup. We could also, well, that's basically it. And I'll leave it at that. And so we can look at some problems together.